Okay, so let XD be a metric space. X is the underlying space and D is the metric. Now consider 2 points X and Y belonging to our metric space and assume that, for sake of simplicity, that the metric space is path connected, so we can find a continuous path gamma parameterized on the unit interval 0, 1, which connects the point X to the point Y. Now we can define the length of gamma in terms of the metric by considering a partition of the unit interval 0, 1, a finite partition of that unit interval, and then taking the summation of the distances between gamma of ti and gamma of ti plus 1. Namely, we evaluate gamma at consecutive points along this partition. We look at the distance between gamma evaluated at 2 consecutive points of the partition, and then we sum up over all those distances. Now, if we refine the partition, this summation will only increase in value due to the triangle inequality, because D is a metric. So we take the supremum over all these possible partitions of the unit interval, the supremum of the summation of the pairwise consecutive distances between gamma evaluated at points on this partition. Okay, so that looks like sum of gamma evaluated at ti, comma, gamma evaluated at ti plus 1, take the distance between those 2 points, and then sum over the partition. Okay, now take the supremum over all possible partitions. That's defined as the length of gamma. Okay, now you can define a new intrinsic metric on your space by taking the infimum. If you consider 2 points in the space now, two points X and Y, let's say. Now we assume that there's a path connecting X and Y. If we take the infimum over all possible paths connecting X and Y of the length of those paths, okay? So the infimum of all paths connecting X and Y of the length of those paths. So basically, that gives us a new distance on a new metric on our space. And if this new metric is equivalent to the original metric, then we call the metric space a length space. Okay, and so somehow the metric itself is kind of there's reflexivity there, in that you can kind of, it's a dual notion where you can use the metric to understand the length of a curve by partitioning that curve into finer and finer subintervals, and approximating the length of the curve by these partitions using the metric. But also, you can construct a variational principle to determine the global distance between 2 points on the metric space by looking at the set of all possible paths between those 2 points and taking the infimum over their lengths. Okay, so this is a nice property, and this property is satisfied. If this property is satisfied in the metric space, it's what's called a length space. Have a great day.